So a big part of tomorrow's assignment is going to involve us finding the roots of different polynomial functions, so I just wanted to remind you how to do that. Firstly, there's factoring, so we're going to take a look at this example here. And we are going to factor, so we're looking for two numbers that multiply to be 8 but add up to be 6, so that should be y equals x plus 2 and x plus 4. Once we're in factored form, we can take a factor and set it equal to 0, so x plus 2 equals 0, and by solving we get x equals negative 2. So this will have a x-intercept that value. When we set x plus 4 equal to 0, we get x equals negative 4 for one of our roots. Let's take a look at the next example. In this one, it seems like a little more complicated to factor. In this case, we have to factor out a GCF first. The GCF is x, so y equals x, parentheses, x squared plus 5x minus 6. We should see if this can be factored. If not, we might have to use the quadratic formula. Y equals x. Two numbers that multiply to be negative 6 but add up to be positive 5 should be x minus 1 and x plus 5, giving us, not 5, 6, giving us the roots of x equals 1 and x equals negative 6. So those are the roots for that example. The next one is partially factored already, which will happen with a lot of these polynomial functions because they get really complicated when they're cubic and to the 4th power and 5th power, so they will be partially factored sometimes. If we try to find numbers that multiply to be 6, will any of them add up to be 2? Well, negative 6 can be negative 6 and 1, which add up to be negative 5. We have negative 3 and 2, which add up to be 1, which means we're never going to get 2, because 3 and negative 2 would just add up to be positive 1, and 6 and negative 1 would just add up to be positive 5. So this means we're going to have to use the quadratic formula for this one. So we'll use x equals negative b plus or minus the square root of b squared minus 4ac. All of this is going to go over 2 times a using this factor. So we're only focusing on the factor here. So we're going to plug in 2 here, 1 here, and negative 6 here. And this is also a 1, and we will try to find out what the roots are using the quadratic formula. So negative 2 plus or minus the square root of 2 squared is 4. Negative 4 times 1 is negative 4, times negative 4 is negative, will be positive 24. All of this is over 2. So we'll get x equals negative 2 plus or minus the square root of 28 over 2. We'll simplify the radical. The largest perfect square that goes into 28 is going to be 4. So x equals negative 2 plus or minus the square root of 4 times 7 all over 2. So we get x equals negative 1 plus or minus, negative 2 plus or minus 2 radical 7 over 2. And if we simplify, the number that goes into all three of these evenly is 2. We get x equals negative 1 plus or minus radical 7 over 2. This is really 1 radical 7, but you don't usually write the 1. So these are the roots for that example. I think I missed a root in the previous example. We also could say x equals 0 is one of our roots, because when you have a factor of just x, it's really a x minus 0. So x minus 0 equals 0 when x is equal to 0. So x equals 0 is also a root for that one. I have a few more to do. This one, for example, this one we get x equals negative 2. This one we get x equals 6, no problem. This one, it's a difference of squares, meaning it can be factored, but you don't have to factor them. For the difference in sum of squares, there is another way to solve them. We can just say x squared minus 4 equals 0. We will write x squared equals 4. Whoops. And then we just have to take the square root of both sides. But when you do that, you have to put a plus and minus on the right side. So we'll get x equals plus n minus 2, which would have happened if we factored this as well. We would have gotten x minus 2 and x plus 2 as the factors, and we would have gotten x equals 2, and we would have gotten x equals -2. So we'd get the same answer if we factored or used the method of square roots. For the next one, we see we get x equals -3. And if we were to set x squared plus 4 equal to 0, we would get x squared equals -4. And now if we take the square root of both sides, we get x is equal to plus and minus the square root of -4, which, if we remember from our previous classes, is x is equal to plus or minus 2i. So this one has imaginary roots, and they wouldn't appear on a graph. The only other type of factor we need to mention is when you have a factor like this. So let's say I had 2x times 3x minus 5. This one, when you try to find its root, you would write 3x minus 5 equals 0. You would add the 5 to the other side, and you'd get 3x equals 5. Divide both sides by 3 and get x equals 5 over 3. So that would be a root of a factor which has a coefficient. 2x is just 2x equals 0, and we can say x equals 0. So these are how you find the roots of different problems. Technically, you can use the quadratic formula here as well, or here as well. I wouldn't recommend it, but I want you to know your options for when you try and do the examples